In a data-saturated world, from market trend to medical studies, how do we separate signal from the noise? How do we make informed decisions in the face of uncertainty? The essential tool is statistics, which is the science of collecting, analyzing, and interpreting data to find patterns and make evidence-based choices. It is the lens through which we can understand the world. Today, we will explore the fascinating world of statistics and its limitations. Stay with me. By the topic applications of statistics. Statistics is applied in almost every field of human endeavor, from daily life to scientific innovations in general. It helps us understand, measure, and improve the world around us. In particular, in everyday life, people constantly rely on numerical factors. It is obvious that people constantly rely on numerical factors, such as comparing prices, budgeting, or interpreting weather forecasts, right? Decisions are often based on statistical reasoning, even informally. So no one can far from using statistics. Statistics can also be vastly used in the application of scientific and environmental research. For example, for the development of new drugs, testing their safety and effectiveness, statistics come to effect. Statistics comes to effect. And statistics is helpful to measure the extent of environmental pollution, track climate trends, and evaluate interventions. Right? In epidemiology, for example, tracking the spread of diseases like COVID-19, identifying risk factors such as smoking and lung cancer, and determining vaccine efficiency or rely on statistical models. Yeah. Genetics, for example, it is a scientific area of study identifying genes linked to specific diseases involving analysis vast data set of genetic information to find statistically significant correlation. The other area of study where statistics is vastly applicable is industrial and manufacturing processes, in which it is critical in quality control, ensuring products meet standards through the statistical process control. This supports process optimization and defect reduction. Right? Statistics also applicable in technology and AI, artificial intelligence. This is nothing but a rapidly growing area of statistics, particularly in machine learning, data science, and deep learning. In machine learning, at its core is a statistical discipline, meaning algorithms learn pattern to make predictions, such as span filter, image recognitions. In data science, where it is blend of computer science and statistics focused on extracting insights and knowledge from data. Right? So statistics is applicable in almost all fields of study, but these are some examples where statistics can apply. Now let us proceed to the use of statistics. The primary purpose of statistics is nothing but to transform raw data into comprehensive and actionable information. Key functions include simplification and summarization of data, hypothesis testing and inference, forecasting and prediction, comparison. For example, this simplification and summarization is nothing but condensing large and complex dataset into a few meaningful figures or visualizations, beginning from data collection, experiments, and their design activities. For example, calculating the average mean or the average or mean income of a country instead of listing every citizen's salary. Right? We can talk with average rather than talking with individual pointers. This is possible through statistics. The other way where statistics is useful is in developing and implementing hypothesis testing. It is nothing but using data formally tests. Using data to formally test a claim or theory, determining if a result is statistically significant or due to chance. For example, testing if a new teaching method significantly improves student test scores compared to the old method, right? So this comparison can also be made through the use of statistics. Statistics also useful for forecasting and prediction, where forecasting can depend on the historical and present data. Forecast the future. Prediction is nothing but how the variation of one variable can be explained by the variation of other variable, right? For example, predicting a company's next quarter sales or the probability of rain tomorrow. The other way where statistics can be useful is through comparing groups with respect to type. So, enabling objective comparison between different groups, time period, or conditions can be possible through statistics. For example, comparing the effectiveness of drug A versus drug B in treating a specific illness. Inference is nothing but drawing conclusions about a large population in general based on analyzing data from a representative sample. For example, surveying a small number of voters to infer the political preference of the entire electorate, right? Of statistics, despite its power, statistics has limitations that must be acknowledged. So, statistics deals only with quantitative information, meaning that it ignores qualitative aspects. Statistics is nothing but with quantitative data or phenomena that cannot be numerically measured, such as honesty, beauty, or culture cannot be directly analyzed statistically. And statistics focus only aggregates, not individual data points, meaning that it does not study individuals, rather aggregates. In other words, statistical laws and conclusions apply to the average or aggregate of a group, not necessarily to any single individual within the group. For example, the average height of a class does not mean every student is that height, but it is true on average. Statistical results are often approximate, not exact, meaning that statistical conclusions are based on probability and estimation, not universal laws like in physics. They are true on average or within a defined confidence level with inherent degree of uncertainty, right? So statistics prone to misuse, or it can be misused or misinterpreted if not handled by experts, right? Meaning the statistics is a tool that can be deliberately or accidentally manipulated to promote false conclusions, such as due to pure sampling method, biased data collection, or selective reporting can lead to misleading results.